Welcome everyone to our presentation. We are going to be talking about making pipelines with AWS. My name is Vaishnavi. I use the she, her pronouns. I am a software engineer at PowerAdvocate, and I have been here for the last 10 months or so. And I also was a previous PowerAdvocate co-op while I was a student at Northeastern, and I'm now here full-time.
Awesome. Thanks, Vaishnavi. My name is Mark. I'm also a software engineer here at PowerAdvocate. And I was also a co-op back in 2017 and came back here after I graduated from Northeastern. And Claire is unfortunately having mic problems, but she is one of our many current co-ops here at PowerAdvocate, just so you know.
Is this better?
Yay!
Oh, yeah, yay!
Yeah, sorry for the issues. This is my first time using Zoom with the work lab, so didn't anticipate how challenging this would be. But yeah, I'm Claire. I'm a second year computer science and math major at Northeastern. And like Mark said, I am a current co-op.
Awesome. So to start off, I'll just take us through a very quick agenda before we dive in. We want to structure this presentation kind of like a problem and solution. So first, we're going to try to set up a need for you before we talk about these pipelines and let you know kind of an issue that we sought to solve with them. We'll describe what these pipelines are at a very high level, and then talk in depth about the AWS services that we use to enable these pipelines. Finally, at the end, we'll have a sort of overview of the system, kind of presenting the solution to the problem that we lay out at the beginning, and then we'll have some time for questions and answers as well.
Yeah, so what is our problem? At PowerAdvocate, we have a lot of data that we store in many different ways. So we store it in different databases, on different servers, things along those lines. This is because when we first collected the data, we stored it in a way that fit our needs at the time. But as time goes on and our needs evolved, we've needed to find ways to combine this data together that comes from all of these different sources. And so here's an example of a problem that describes that. So we have a database that has a table called locations, and it's in an Oracle database because we want it to have relations with other pieces of data in our database. And then we also have a table called events in a MemSQL database, which to summarize is just one that is really able to handle aggregating data quickly. So we can do large computational queries on that. And so the kind of question that we can put together from these is that how can we find out where an event was that I went to? So what was the location of the event? We can ask other questions like how many people were at this location by figuring out how many people were at events and things along those lines. And so how can we combine this data together? It's stored in 2 different tables, in 2 different databases, on 2 different servers. And so yeah, how do we do this?
So one of the approaches we've taken here at PowerAdvocate is trying to combine all of our data from these different scattered databases in one central location that we consider a source of truth. These are often called like a data warehouse, which is the language I have here on this slide. Sometimes they're referred to as data lakes, but the idea is that it's a database designed to handle like high volume exports and imports. So you can dump like entire tables and entire other databases into this, and it's kind of just a central repository. And so once we had decided to go through this kind of design paradigm to manage our data and keep it all in a central location, we needed ways to pipe our data around. For example, the Oracle and MemSQL databases that Vaishnavi mentioned on the prior slide are being like queried and read from by users of our platform all the time. They're being written to all the time. So it's hard to have these in like a steady, stable state. And so that's what we're trying to accomplish with these pipelines, where we're constantly syncing snapshots from one of the databases like Oracle to Redshift and then pushing data from Redshift to MemSQL to then be read by clients querying our databases.
And so the way we handle the problems that Mark and Vaishnavi just talked about is through using pipelines. For our purposes, you can just think of a pipeline as a series of steps that manipulates data. So we want to move it around between different databases, process it in different ways, maybe insert or delete it from specific tables, pretty much anything you can think of. And one nice thing about our pipelines is that we've set them to run on a schedule. And so everything about our data processing can just be automated and work on its own. And then we also want to clarify that we're talking about how we have made pipelines using AWS. There's an AWS service called Data Pipeline, and that's not what we're talking about here. Yeah, so before we go any further, we should probably explain what Amazon Web Services is. Basically, it's a toolbox of different cloud computing services. And if you're not familiar with cloud computing, you can think of it basically as renting someone else's computer. So the nice thing about this is that you only pay for as many or as few resources as you need. So you don't really have to worry about your capacity changing, anything like that. And then also, Amazon takes care of managing all the physical infrastructure. So the servers, the data centers, everything, you don't really need to worry about that. You can just work with whatever you need. And then finally, AWS has a lot of different services, but today we're just going to talk about the ones we use for pipelines. So I believe that's 5 of them.
The first service we wanted to dive into today is called Lambda. Lambdas are short-running serverless functions. And serverless is just another word for cloud computing, and which in Lambda's case is a way to run code without having to personally manage the server that it runs on. And Lambdas can be written in all languages. You'll see here that this Lambda is written with JavaScript, but Lambdas can also be written with Java, Python, Go, Ruby, whatever language your heart so desires. And Lambdas also can be very simple functions. All it needs to do is take in input and return output. It doesn't have to be anything complicated, like any of your homework assignments level complicated, or like a whole application. They're designed to be short. At max, they can run 15 minutes. So very, very quick. And this here is a perfect example of how simple Lambdas can be. We're getting passed in an event, and this event has 2 parts, greeting and club. And so with these, we can put them together and then return a club greeting. So you'll see in the examples below that if we pass in a greeting that's called hello and a club that's NUWIT, our response is hello NUWIT. And then because this is a function, it can take in different arguments and then return different responses based on those arguments, just like any other function. And so if I were to pass in another event into this Lambda with the greeting hello and then the club new hacks, then my response would be hello new hacks, just like you would expect with any function. Oh, sorry. And so as an example of how we use this to tie into our pipelines, Lambdas are a really easy way for us to communicate and connect AWS resources to our own backend. So if at PowerAdvocate we've developed code that we need AWS services to talk to, Lambdas are a great way to bridge that gap. And the next AWS service we'll be talking about is a good example of that.
Yeah, so the next service we want to talk about is called AWS Step Functions. And we also sometimes call them state machines. They're basically interchangeable terms. So a state machine is just a series of tasks that AWS executes for you. And that's basically what we think of when we say pipeline PowerAdvocate. And the way that a state machine is defined is as a JSON, which stands for JavaScript Object Notation. It's just a data format. And what you need to know about it is that, as you can see here, we have pairs of attributes, which are the strings in blue on the left, and values, which are the strings in green, and then the two red, the integer and the Boolean down here. So this is a very simple example of a state machine. You can see it represented as a diagram in the upper right. Amazon will do that for you when you give it the JSON, which is nice. And we can see that we just start at the first step. And you can see that the resource it references is just a lambda, as Vaishnavi talked about. And then you'll just proceed to the next step, which is also a lambda. And we can see that this one has a specified timeout of 600 seconds. The timeouts are really useful for our pipelines because if something is going wrong for whatever reason, and it's never going to finish, we don't want to let it run forever. We want it to time out so that we know that we have a problem and we can rerun it if we want. And then these are just more examples of more complicated things you can do with step machines. So it doesn't always have to be like linear logic. You run the exact same steps one by one. So on the left, we just have an example of parallel processing. So to save time, we can just export all those files at the same time. And after we're done with that, we'll move on to the next step. And then on the right, we just have some more complicated decision logic. So basically, it will keep waiting and trying the step at the top before it finally works and it goes to the end. And the third thing we want to talk about is CloudFormation. So that's how we make our pipelines. We'll explain that in a little more detail on the next slide. But basically, what CloudFormation does is it allows us to create stacks. And a stack is just a collection of different AWS resources. So for our purposes, our stacks usually have lambdas, state machines, event rules, which we'll talk about a little bit later, and also, sorry, the voice. So lambdas, state machines, event rules, which we'll talk about later, and they can also contain other stacks, but they can basically have any kind of resource you want. These are just the ones we usually use. And so a stack also has parameters, which are just keys and values, and the person who creates the stack can specify basically whatever they want. So an example of how these are useful for us is that we can have a key called scheduling enabled and set it to yes or no. And this, we can code our pipeline so that when it's yes, the pipeline will run automatically, and when it's no, it won't. So this is useful for us when we need to debug things. And so we create the different stacks in CloudFormation by using a template, which is just a file that's either a JSON or a YAML, which is another data format. So we can see here, this one is a JSON. We just have some parameters at the top, and we have some resources at the bottom. And overall, CloudFormation is based on this idea of infrastructure as code, which basically means instead of manually creating a bunch of different cloud resources and then manually having to manage all of them and deal with them, we can have one file that describes everything we want to make, and Amazon will create that for us. So that avoids a lot of human error and saves us some time.
Awesome. Thank you, Claire. The next service I'm going to be talking about is DynamoDB. This is a database offering from AWS in the cloud. Before I talk about any specifics, I want to kind of highlight why people use this. It's great because DynamoDB is one of the most high availability database offerings you can get. Amazon will host your data in as many regions as you want them to around the globe, and you can have as many servers as you want running in each of those regions. So if you're a huge, massive tech company, you can have data kind of decentralized all around the globe, able to be read very quickly from anywhere. Some of the specifics about DynamoDB are that it's a NoSQL database. So first of all, that means non-SQL. Essentially, it just is a way to differentiate these kind of databases from relational databases. So a NoSQL database is really any database that is not relational. So to explain that difference, I have this kind of image here on the right. In a relational database, you can see that we have these two entities, articles, like for a newspaper or something, and then comments on those articles. And they're stored in two separate tables. And the idea is that these comments would each have an article ID or something of that nature, which kind of points the comment to its associated article. In a NoSQL database like Dynamo, you don't get those same kind of relationships. And so you have everything stored as one object or one entity, and you have to retrieve the entire thing all at once. So here, the articles themselves have a title and have comments. And when you retrieve a single article, you kind of get everything else along with it. Some of the things you have to be careful with these NoSQL databases, though, are that they're not built to do sorting or filtering. So I couldn't, for example, retrieve all of the articles on the website sorted alphabetically without doing some like really expensive computation and waiting a long time for the data to be returned to me. And I also would have trouble filtering these if I wanted to find articles that had comments from a certain user or something along those lines. Dynamo would also really struggle to run a query like that. So it's important to just know what your software was built for before you dive into using it, and just be aware of its strengths and limitations as you go. On this next slide that we're about to pull up, we can go into a little bit more detail about how this is stored. So we've already mentioned JSON data a few times on previous slides, and AWS uses that again here as how it represents the rows in this database. Each row is essentially just a JSON object with as many fields as you want. So to break this down into the terminology that AWS uses, each table is something that stores similar entities. So here we're looking at a person table, and we see 3 different examples of people represented in JSON data. Each of these people is an item according to AWS. So that just means it's a record, a row that you can look up and retrieve. And then finally, each person has attributes, which are each of the keys you see here, like person ID, last name, and first name show up in all of them. But one key thing to highlight here is that these people look kind of different. You'll see that the top one has a phone number associated with them, while the other 2 don't. The middle one has an address, but it's actually formatted differently than the third person's address. We'll see that the middle person has a zip code, while the third person has a postal code. And then finally, the third person also has like a favorite color, which neither of the other 2 have. And so as long as each of these records has a person ID, which is the primary key on the table, and you see it in bold here, all of the other stuff is completely optional, and you could attach anything else you wanted to. And then say you wanted to add a new person to this table, and you wanted to give them like a favorite food field as well. Even though none of the other people in the table have a favorite food, you can just throw that in there, save it to the database, no problem. So you get a ton of flexibility as well. So that was all we wanted to cover with Dynamo. The other AWS offering I'm going to be talking about is EventBridge. This is essentially Amazon's implementation of an event bus or an event service, which is a very common design paradigm. This isn't something that's like just used by us at PowerAdvocate or just used in AWS. This is a common implementation to solve problems that a bunch of companies have used. And essentially the way an event bus works is that you can subscribe to different events. Usually this is done with a key, like an event name or something, which is just a a universal identifier for that event. So you'd subscribe using its name. And then whenever an event like that is produced somewhere in the platform, you would be notified of it. So an example of this might be if you had a website with a long running process, say the user is going to like click a button and it's going to take 20 seconds or so to load and finish doing what it's doing. If another part of your code base wanted to be notified when that event finished, you could use an event bus to solve this problem, where when you finish loading the data in one piece of the code, you would send an event out. And then if someone else had subscribed to that event, they would then be notified that you had finished. So Amazon essentially just offers us all of that functionality here through the event bus service, which they call Event Bridge. Some of the terminology that they use is an event is essentially just a piece of data that represents a change in the environment. So like I said, it has a key associated with it for lookup and for other people to subscribe to. And then it has some other data like metadata associated with the event that can send more information. You have rules, which you see is the next step in the arrow on this slide. And the rules essentially tell the event bus who to send the events to. And this is what you would actually configure when you were setting up the event bus. You would fill out these rules and enter them into AWS to set up how you want these events to be sent out. And then finally, on the right, they were labeled as consumers in the diagram, but the AWS documentation calls them targets. So that's what I'm going to go with. And these are just the final receivers of the events who get notified when the event is sent out. And I will talk in a little bit about how we use this in our pipelines, but for now, we just wanted to cover the system. And before we dive into the specifics and how we used all these systems to kind of solve our pipeline problems, we're going to take a quick break to answer questions specifically about the AWS services, if there are any at this point.
This is a question, I think from earlier, but I wrote it down. Why would we want to use like a step function rather than like just like making your own like functions in your code and just like kind of like triggering them one after another? Like why use this like extra step, I guess?
Yeah, Vaishnavi and Mark, feel free to jump in if you have any other answers, but I think just like the convenience of having them all run at once instead of, I don't know, if you think about like individually triggering all of those, I personally don't know an easy way that we could do that.
Yeah, I think it's just about like leveraging the tools that we have available to us. If we wanted to do this ourselves, which I think we certainly could, like you raise a good point, we would just have to better manage our servers and resources, which is really what we're using Amazon or AWS for here.
And they have a lot of functionality too, as Claire mentioned, like we can schedule them, or I think we do that with Cognition, but we can schedule them. There's all sorts of like logic already built into it. So that's also just like super helpful to have a lot of that work already done for us. If that answers your question.
Yeah, great, thank you.
Any other questions?
All right, want to dive into the next section?
Yeah.
All right, cool. So we're going to go through and try to talk about how each of the services we just described were used to help us enable these data pipelines. So to start with, we're going to be talking about something we call a brokered check. And I'll talk a little bit about what that means in a second, but first to just digest the information on this slide, we have the pipeline on the left. We talked about how these are represented as state machines or step functions. And like Claire said, you can just use them interchangeably. On And so we have this series of steps that we want to execute, and we consider that a pipeline. One problem we ran into early on as we were implementing this is that there's a lot of shared steps across different pipelines. So we might have two pipelines that run independently of one another, but both of them need us to export like the users table from one database to another. So when one of those pipelines runs, if it's running right after the previous pipeline, we don't want to have to duplicate the export of that table if it just got duplicated like an hour ago or something. We don't want to have to re-export it because the data is already pretty fresh, and it would kind of waste processing time to do the whole step over again when we don't need to. So to deal with this problem, we came up with the idea of a brokered check, which is just that each of these steps has a frequency when it's supposed to run. So for the example we were talking about, maybe we want to export all of our users once a day. And so when we have this frequency that we want to run the step, we can then check to see when the last time it was run and see if like we need to run it again if it's been enough time since the last time it was run. And that was the goal we wanted to accomplish. So to do this, we used Lambdas and DynamoDB. So within the pipeline itself, we will make calls through this kind of brokered service to do the check. What that actually looks like is that a Lambda will execute. Like we said, these are very fast running servers that get kind of spun up and spun down on demand. So we would really quick spin something up, execute a quick chunk of code to kind of fetch some information from DynamoDB, get a response back, which is what you see in the image at the bottom on the right there. And then based on the response, we will know when the last time this step was run, and we can return to the state machine from the Lambda the instructions to either, yes, go ahead and run this step because it's time, it's been scheduled, or to say like, no, this step has already run recently, we can skip over it and move on to the next thing. And so on this next slide, now that we know what the brokered step is and how it's used, we can talk about kind of a whole pipeline executing. So to start with, this pipeline again is represented by a state machine. This would have been created using a cloud formation template, which we talked about earlier. And those are the JSON representation of a pipeline stack where you kind of define all the objects you need, and then Amazon AWS will create it for you. So once that's been created, we have this step function here, and we have made a brokered check. We sent that check out and got a response and said, yep, go ahead, we want to execute this pipeline step. So what does that actually look like in practice? Each pipeline step kind of starts as a Lambda function, which gets very quickly spun up and usually just sends an HTTP request to our backend. And then our backend, we have all of our own logic where we want to kind of do the export, run the queries on the table that we need to run, get all the data where it needs to go. And then once we've handled all of that on our backend servers, we will send either a success or a failure callback, which is either just a URL saying like, yep, the export went well, everything's where it's supposed to be, or an HTTP request that says like, no, we didn't do what we wanted to do, so something went wrong, and we either have to retry or enter a failure state. So once we send that call back by sending an HTTP request, it actually gets listened to by EventBridge, which is the AWS Event Bus service we talked about. So it receiving a request from that URL is the event coming in, and then we've configured rules to send that event out to a target that is the original state machine in the top left that kicked this whole process off. So once we have then sent that event onto the state machine, it will recognize like, oh, this step has finished and we can move on to the next step. And then we would follow the arrow from one state to another and continue going and repeat the whole process over again. And we would start with like the brokered check and then go through the whole same process. And so now we're going to take kind of a moment to talk about the overall system and some of what I think is like particularly cool about it. So I hope you can see that there's like quite a bit of complexity here. And we've kind of generated all of this logic and behavior without really writing any code, which is, I think, pretty cool. We configured all of this using JSON data, essentially just keys and values about how we wanted the system to perform. And then from that, we've been able to create this kind of complex entity that carries out these steps in a very like regimented process, but we haven't actually had to write that much code to do it. And that just goes to show when you have these tools available to you, the more you know AWS and what these tools allow you to do, the more you're able to combine them into unique solutions that are kind of handmade for the problems that you're facing.
And so with that, let's tie it back into the problem that we posed at the beginning of this presentation, which is that we had a table that was that had like a bunch of locations in it. And then we had a different table and a different database in a different server that had a bunch of event data in it. So how can we bring this together? One potential solution to this is that we can create a step function, deploy it with CloudFormation that exports data from both the location and event tables on a regular basis that we can schedule to run every day or however often we need to run. We can process the exported data and join it together in our data warehouse, which is where we combine a lot of data and do a lot of processing on it. That is too difficult to do in other databases. And then once that kind of processing is over, we're able to put that back into a database that's visible to clients, whether it be Oracle or NoSQL. And then from there, we're able to have our front end and our application hit that database and then display that combined data in whatever format we desire. So we can then say like, oh, what is the address that this event occurred at? And can answer questions like that. And so while this works for us and is how we do things, what does this leave you with? There's actually some things that you guys can all do with pipelines yourselves. AWS isn't something that you just need to do at a company or only something that you can use at a company. It's really easy for y'all to set up your own AWS accounts by yourself. And a lot of these services you can use to some degree for free. Definitely be careful if you do try this and make sure that you are only using things for free because it can be easy to have to pay for things. But it is definitely possible to do so many different things with AWS for free. So you don't even have to spend any money on it. And so some of these things that you can do are you can find out when there are openings for concert tickets or more importantly, vaccine appointments. And so the way that you could do this is if you had a regularly scheduled state machine that could scrape the concert ticket website or vaccine appointment website, and then you could process it with your state machine, so on and so forth. So that's definitely a possibility. Another one is that you can automate regular text reminders to yourselves. There's plenty of ways to do this. One of them is using a service that we didn't really talk about today called SMS. So you're able to text yourself with that. And because state machines pipelines can be scheduled, you can now text yourself to do things like take your vitamins every day or something, if that's something that you need to do. Does anyone have any questions?
I just wondered if you could clarify what some of the reasons might be for the process failing. So remember, if you go back to that diagram, you send a request and then sometimes there's a failure and your process doesn't end up running.
Did you mean this one? Just a quick clarification.
Yeah, so those 6 failure callback, why might you get failures? And then why might it all of a sudden start working?
Yeah, so one example is with network requests. So for example, if something goes wrong trying to connect to our backend or to our databases, that would be a case where it could fail, and that could just be literally like an internet problem, or for something that our database temporarily goes down, but it could be spun up again. So if that pipeline were to be run again, it would be able to fix itself without us actually having to do anything if it just went down temporarily. as an example. Mary and Claire, if you have another example too.
Yeah, one thing I can think of, I'm actually not sure like if this is the exact kind of success fail callback that we're talking about here, but for one of the pipelines I work on, we need to get a certain file from, I think it's called Airflow, and that's just what our data science team uses to send things. So sometimes because of something on their end, it doesn't send the file back correctly, and so the pipeline will fail.
Yeah, sorry, I do like data engineering. And so whenever I get failures, it's because there are dependency issues and like you're running something every day and it's dependent on something else that's supposed to run every day, but that failed because someone's package somewhere broke or changed or method somewhere disappeared. Then you get a failure and there are like 500 failures in 5 different places for no reason. So dependency issues, gotta manage those.
Yeah. Are there any other questions?
Yeah, I think we can also answer questions about like, maybe not exactly pipelines in AWS, but just like, I don't know, co-op, PowerAdvocate.
I guess this is more generally about AWS, but how do you figure out, because like I've browsed through AWS's various services and there's like hundreds of them. So like how do you figure
Yeah,
out
definitely.
this is one that'll be good for us and this one wouldn't be? And like how do you navigate that? Is it just like a ton of research, or like is there like someone who knows all this stuff already, or like how do you kind of go about figuring out what to use and what's appropriate?
I can take this one. I think for us, it's closest to there's someone who already knows everything, in that we have like architects at our company whose entire job it is to like understand these services and how we can best make use of them. But I relate to the struggle because it's very overwhelming when you look on AWS and you're presented with like 30 or 40 different services to potentially use. But I think my best advice would be, pick a few that maybe you've heard of, or maybe that you heard of from this presentation, and try to use like one of them in a project or something. And even that is just like great experience. It's not like you need to master all of these right away. Just doing something small with one or two of them could be great.
Does anyone have any questions? If not, that kind of concludes the end of our presentation. So yeah.
Great. Do you guys have like a contact card or something if people have questions afterwards, or I guess you guys can like put emails in the chat or something?
Yeah, I didn't come prepared for this, but I can drop something.
Another option is you guys can email us with all your relevant contact stuff, and then we can throw it in our follow-up newsletter on Thursday, I believe.
Oh yeah.
So if you are feeling put on the spot or you forget something, don't worry about it. Just let me know and I can send it out.
yeah, we can drop all of our emails here and then potentially send them again to you to put them into the newsletter.
Well, thank you guys so much for coming. This whole like thing is like a huge part of data engineering in general. So it's like cool to see like what I do on Google Cloud Platform, not AWS, but like same difference. Like in presentations, like I do that too.
That's so cool.
But yeah, thank you guys for coming. We really love hosting talks like this because they're really great exposure. So for everyone else here, I hope you learned something new and you got to understand something a little bit better, or at least get introduced to something you didn't know about before. But I'm gonna give your night back to you. We ended a little bit early. I hope you continue to enjoy your evening. And yeah, thanks for coming to our NUWIT events. This is like our last real event for the year. So we're so happy you guys have come. We hope you guys have enjoyed the lineup we've had so far. And this is the end of this e-board. So we hope you guys have liked us too. And we'll see you next week for elections.